Hello guys, my name is Ravi Kumar. Yes, we are discussing today open pipe. Okay. In the previous lecture, we have calculated that closed pipe problem. Closed pipe means this is what we are taking. Actually, in the previous class also we have taken the same. If this is closed, one side is closed and one side is open means that is closed pipe. But now both ends are open. Both ends are open now. Okay, so let me discuss first what is the question that explain the formation of stationary waves in air column enclosed in open pipe. In the previous very first question is explain the formation of stationary waves in stretched string. Stretched string and loss of transverse wave is different question, and stationary waves of open pipe is different question. And now derive the equations for frequency of the harmonic produced. Okay, so if the frequencies are decreasing, that means we are calculating the frequencies of the different harmonics are produced. Okay, now the open pipe is nothing but a cylindrical tube. This is what the cylindrical tube, open at both ends. So cylindrical tube having an air column, if the both ends are open, is called open pipe. Where the particles are freely vibrating, no? So freely vibrating, always open ends form antinode, not node will form at open ends. At closed ends 100% nodes will form, but at open ends antinodes only will form. That's what we are taking. Here is antinode, here is also 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 antinode. If you don't know antinode concept, then go for the formation of stationary waves in stretched string, very first question of our channel. Okay, so here are the fundamental frequency, first harmonic and second harmonic. We are discussing just like closed pipe problem. So if you are understand that is first closed pipe question, then this question is very easy, nothing this one. Okay, so for that case I am taking the fundamental frequency. So fundamental frequency is nothing but, or we can call it as first harmonic, if the stationary wave vibrate with single loop or double loop or half loop is nothing but, so I am telling you again in this question, so that here is exactly from this loop to this one. So from node to node is nothing but that is lambda by 2, and from node to node again this is again lambda by 2. So this is completely wave. Completely wave is nothing but this is totally lambda, no? This is totally lambda. But we are discussing here antinode to antinode, no? Antinode to antinode is nothing but antinode to antinode. So this distance is nothing but lambda by 2, no? So this is lambda by 4, this is lambda by 4. Forming this one is 1 by 4th loop, and this is also 1 by 4th loop. 1 by 4th will form 1 by 2. That is what we are taking. The single loop is called fundamental frequency. That's why the length is equals to lambda by 2. That's why the length is equals to lambda by 2. So this is what we are taking, and this is what the first frequency or first harmonic. Okay, so we have the expression that is F is equals to V by lambda, that is V is equals to F lambda. This expression already we know. So from the diagram we can say that is L is equals to lambda 1 by 2, so lambda is equals to 2L. So this is what we are substituting here in this expression, so that F is equals to V by 2L. This is very important expression, that is fundamental frequency. And second harmonic, or it is also known as first overtone. Second harmonic or first overtone. If the stationary wave vibrate with two loops means that is forming first antinode to it is starting. From antinode to it is starting like this, antinode to node, and again antinode to node, again antinode here, antinode to node, and then again it is forming antinode. So like this. Okay, so actually from this to this it is lambda by 2, and from this to this again lambda by 2 this one. So lambda by 2, lambda by 2, lambda. So that's what we are taking, that 2 lambda by 2. For my calculation purpose, I am taking that 2 lambda by 2. 2 gets cancelled, lambda it is only we are getting. Okay. So that is L is equals to 2 lambda 2 by 2. This is what we are substituting in. F2 is equals to V by lambda 2. So here I am substituting that lambda 2 is equals to 2L by 2, because L is equals to lambda 2 lambda 2 by 2. So that is what we are substituting in this expression. So that these two will be coming upwards, that is 2 into V by 2L. V by 2L is nothing but that is F1. So 2 into F1. And next we are taking the third harmonic or second overtone. If the stationary wave vibrate, then 3 loops are formed. So now the loops are 3. So like this we are taking again, and it is forming from antinode to antinode. This is what lambda by 2, no? Already we know. So from antinode to antinode again. This is also lambda by 2. And from antinode to antinode again lambda by 2. So lambda by 2, lambda by 2, lambda by 2. 3 lambda by 2. Done? So 3 lambda by 2 is nothing but lambda 3 is equals to 2L divided by 3. Because 2 is dividing, here multiplication. Here 3 is multiplying, here division. So lambda 3 value I am substituting in this expression. So that is F3 is equals to V by lambda 3. So lambda 3, please we are substituting this expression. So that 3 is multiplying here. That is 3 into V by 2L. V by 2L is nothing but that is F1. Again we are substituting, that's it. So the relation is open pipe. For the frequency relation is F1 is to F2 is to F3 is to so on is equals to 1 is to 2 is to 3 is to 4 is to so on, like that. So this is what the end of the question of open pipe. Very important question. And the last time for your seniors this question came. Okay. And the numerical question is, an open organ pipe of 30 centimeters is long is sounded, and if the velocity of the sound is 330 meter per second, and what is the fundamental frequency of the vibration of air column? And he is given what are the given conditions. You should write, you must write the given conditions. If you are writing this given conditions, then you will be getting almost half mark to 1 mark. And if you are doing this explanation, almost 1 to 1.5 mark. Okay, depending on the mood of the examiner, they will give you this type. Okay. Better write given conditions. Given are 30 centimeters is equals to 3 into 10 to the power of minus 2 meters. Why I am converting here? In sound is in 330 meter per second. So you have to convert this 30 centimeters into meters. And substituting these two expressions is equals to F1 is equals to V by 2L, because he is asking fundamental frequency. So that is F1 is equals to V by 2L. So that is V is nothing but 330 divided by this one. If your calculation, then 550 hertz we are getting. Okay. Hope you understood the video. Have a nice day. I will meet you in the next lecture.